this is Mr. Benji. In this tutorial, I will demonstrate another way to obtain the median of a set of numbers. Now, keep in mind that one question you always need to ask is to ensure what kind of a variable a certain distribution is intended to describe. In most cases, when no further information is given, by default, we're referring to discrete variables. However, when and if you are tasked with figuring out the median of a continuous variable, median of a set of numbers, median of a distribution of numbers describing a continuous variable, you will need to be careful and take into consideration just highlight this here, and take into consideration the fact that the score of 6, for example, the score of 6, when we say that there's one score of 6, we're suggesting that there is one score that falls within the real limits. Do you see? The upper real limit of 6.5 and lower real limit of 5.5. Do you see? Now, one way, of course, in a previous tutorial, we've shown how to figure out exactly where the median is by considering the midpoint that would cut the entire graph right here, that would divide two areas on in this histogram, the two areas that are the same. So as in the point on the number line that would dissect the histogram into two equal halves. By two equal halves, these are two halves with the same amount, with the same area. Okay, the same area. Now, is this the only way to figure out the median for a set of numbers involving a continuous variable? No, it isn't. It isn't. And here's why. Here's a concept for you to recall. Recall that the median is defined as the middle number of a distribution. And by definition, this middle number is the number where half the scores would be smaller than it and half the scores would be larger than it. That is to say, essentially the middle number is also the 50th percentile. Okay, the 50th percentile. Okay, by percentile rank, the 50th percentile as percentile rank. Okay. Now, if that were the case, then what we can do is to use our knowledge of how to figure out percentile ranks, to look at what is the corresponding score of X for the percentile rank of 50th percent. Okay, the 50th percentile. And which means we'll quickly construct two extra columns. And these two extra columns are your cumulative frequency as well as your cumulative percentages. And for the sake of expedience, I have already included the numbers here. So we've got a column of cumulative frequencies as well as a column of cumulative percentages. Okay? And the question again is to figure out the median. Median is the 50th percentile. That is to say, now we can set up the situation in such a fashion. Here's where we begin to set up the analysis that we're looking at. Okay? Now we know that 50th percentile is the median. 50th percentile is relevant to the position of the number which represents the median in the score of X. And 50th percentile is between according to the table that we've constructed, between the cumulative percentages of 66.67% as well as 25%. The next is to figure out the relative distances. Do you see the relative distances between the 50th percentile against the upper and the lower? The known cumulative percentage that is above it and the known cumulative percentage that is below it. And assuming that we've decided to figure out the answer using the top numbers, using 66.67% as well as the score of x equals 9.5 as the starting reference. And if you proceed to complete the analysis, you would see that we need to subtract 0.4 from 9.5. Again, 9.5 is the top x score that we've decided to use as the starting reference point. So to proceed, all we need to do is simply to complete the arithmetic of 9.5 subtracting 0.4, which gives us 9.1, and voila, this is the median. Okay, this is the median. Okay, what you can do, of course, is to reconstruct the histogram on your own, to reconstruct a histogram that represents this frequency distribution table. Do you see? Reconstruct the histogram that represents this frequency distribution table. And I encourage you to explore using the area method, okay? Figuring out the exact point along the number line where this number is, or what you can, one quick way for you to cross-check is as soon as you construct the histogram, at the points of 9.1, okay, at the point of 9.1, draw a straight line through, and well, it would be through the 5 squares, that denote the score of x equals 9. The 5 squares because, well, if you go back to the frequency distribution table, the score of x equals 9 shows up 5 times. Okay, shows up 5 times. And if you draw a line from 9.1 onwards perpendicularly, you would construct a line that essentially divides the histogram into 2 halves. Toward the area toward the left side of 9.1 is the same area as the area towards the right side of the histogram. That's what you would find. Okay? Proceed, verify my claim, and I certainly hope again that this tutorial helps. Hit the like and subscribe buttons to stay up to date of quality tutorials that can help you succeed in your studies. You've been watching Mr. Benji at Mr. Benji Now on YT. I'm a college instructor in Vancouver, BC, Canada. Until next time.